Добрый день.
Okay, good morning, dear colleagues and guests. Our broadcasting shall be delayed. Let me announce a short technical break until we eliminate the technical issues. Thank you. Dear colleagues and guests, let me continue our session of the Dissertation Council for the defense of thesis by Markov Nikolai Sergeevich for the degree of candidate of Physico-Mathematical Sciences, Specialization 010204, Solid Mechanics, on the theme on problems of mechanics for layered structures with inhomogeneities. According to the order of St. Petersburg University, dated the 12th of December 2019, number 12093/1, me, Grekov Mikhail Alexandrovich, Doctor of Physico-Mathematical Sciences, Professor, Department of Computational Methods and Continuum Mechanics at Petersburg University, was appointed Chairman of this Dissertation Council. In accordance with the order of St. Petersburg University of the 23rd of March 2020, number 2304/1, our meeting shall be held in the remote access mode, which includes my colleagues, members of the Council, and the applicant. Let me introduce my fellow Council members. Bauer Svetlana Mikhailovna, Doctor of Physical and Mathematical Sciences, Professor, Department of Theoretical and Applied Mechanics, St. Petersburg University. Svetlana Mikhailovna, can you see and hear us? Yes, I can see and hear you. Yeah, we cannot. Now we can see you. Professor Altenbach Holm Johannes, Doctor of Technical Sciences, Otto von Herike University, Germany. Holm, can you see us and hear us? Yes, I am very happy to see you. I'm also glad to see you. Goes both ways. Next, in the same communication channel, we have Melnikov Boris Evgenovich, Doctor of Technical Sciences, Professor of the High School of Mechanics and Control Processes of St. Petersburg Polytechnic University of Peter the Great. Can you see us? Boris Evgenovich, can you hear us? Good. Polyansky Vladimir Anatolovich, Doctor of Technical Sciences, Acting Director of the Institute of Mechanical Engineering Problems of the Russian Academy of Sciences. Can you see and hear us? Yes, everything is okay. Excellent. Next, in the same communication channel, we have the academic advisor of the applicant, corresponding member of the Russian Academy of Sciences, Professor, Doctor of Physical and Mathematical Sciences, Professor of the Russian Academy of Sciences, Director of the High School of Theoretical Mechanics of Peter the Great, Krivtsov Anton Miroslavich. Anton Miroslavich, can you hear us? Yes, I can see and hear you. That's okay. And the applicant himself, Markov Nikolai Sergeevich. Can you see and hear us? Yes. Excellent. So, all the members of the Dissertation Council, as well as the applicant and his academic supervisor, are in touch. We can all see and hear each other. So, dear colleagues, since our meeting is held in remote access mode, I would like to warn you that our meeting may be accompanied by issues of technical nature. I ask all the participants to watch the procedure, and if you stop seeing or hearing someone in case of any technical failures, please inform me, and I will announce a technical break until these issues are eliminated. Let me also inform you that our meeting is being recorded and broadcast online at St. Petersburg University website, and the speeches are being simultaneously translated from Russian into English or from English into Russian. The applicant's page currently has an email address to which anyone can send questions to the applicant regarding his thesis. These questions shall be forwarded to me, and I will voice them during the discussion. The questions should be related to the applicant's speech and the content of his thesis, and it's obligatory to indicate the name, position, place of work of the author of the question. Also, let me mention that questions that are not related to the scientific discussion, to the discussion of the thesis, to the text and evaluation of the thesis will not be voiced. According to the federal law, the 23rd of August 1996, number 127, on science and the state scientific and technical policies, in Petersburg University has the right to award academic degrees independently. The corresponding order on the procedure for awarding academic degrees at Petersburg University, on the basis of which we are holding this session of the Council, was issued on the 1st of September 2016, number 6821/1, hereinafter the order or the procedure correspondingly. In accordance with this order, a session of the Dissertation Council is duly constituted if at least 2/3 of the approved members of the Council are participating, but not less than 4 persons. Our Dissertation Council consists of 5 members. All the members are present all in the remote interactive mode. Audio-visual contact has been established with all of them. So we have the quorum. I instruct the curator of the defense officer of the Dissertation Council Activity Support Department, Karpova Natalia Vladimirovna, to draw up the attendance list in which the Dissertation Council members present and the applicant for the degree shall be recorded and indicate their work mode, in this case remote access mode. Let me set forth the following procedure for today's session of the Dissertation Council, approximate duration of approximately 2 hours. First, the chairman's summary report on the main content of the documents submitted by the applicant and their compliance with applicable requirements, answers to possible questions, approximately 5.
Второе.
Second, a brief presentation by the degree applicant outlining the key points of his study, approximately 15 minutes. Third, questions to the applicant strictly on his report, no more than 2 minutes per question. 4, answers of the applicant, maximum 5 minutes for all questions. 5, speeches of all the members of the Dissertation Council with their reviews, stating their opinions, questions and suggestions to the applicant, no more than 10 minutes for each speaker. Speech of the chairman and his review, approximately 10 minutes. 7, answers of the applicant to questions and remarks of members of the Dissertation Council, not more than 15 minutes. Here, I'd like to add that answers may follow each speech of a member of the Dissertation Council, or we can have them all in the end. It depends on how many comments there are. I believe it's better to answer all questions after each review, after each speech of the Dissertation Council members. Open discussion, speeches and questions to the applicant strictly on the topic of his study, no more than 5 minutes per each question. We shall also voice questions sent by email, if any. 9, final answers of the applicant to questions asked, no more than 5 minutes. 10, this 5-minute discussion before the open voting on awarding or not awarding the academic degree to the applicant. For the time of this discussion of the council members, voice shall be switched off. 12, open individual voting and counting the votes by the chairman of the Dissertation Council, and the results should be recorded in the minutes of the meeting. 13, a decision on awarding or not awarding the St. Petersburg University academic degree to the applicant. 14, closing remarks of the applicant, no more than 2 minutes. Dear colleagues, do you have questions or objections to this procedure? Silence means no one has any questions. You have a question? No, we don't. Well, that's good. If no one has any objections, let's start implementing the procedure. But first, let me remind you to switch off your mobile phones. Thank you for your attention. Well, let me start the meeting with our first item, Chairman's Summary Report. The thesis by Markov Nikolai Sergeevich for the degree of candidate of Physico-Mathematical Sciences, Specialization 010204, Solid Mechanics, on the theme on problems of mechanics for the layered structures with inhomogeneities. It was accepted for defense by the order of the Academic Secretary of St. Petersburg University on the 10th of December 2019, order number 12131/1. The Dissertation Council was appointed by the order of the Academic Secretary of St. Petersburg University on the 12th of December 2019, number 12275/1, and I have already introduced its members to you, dear colleagues and guests. Markov Nikolai Sergeevich wrote his thesis at the St. Petersburg Polytechnic University of Peter the Great. His academic advisor, Markov Nikolai Sergeevich, is a corresponding member of the Russian Academy of Sciences, professor of the Russian Academy, Doctor of Physical and Mathematical Sciences, director of the High School of Theoretical Mechanics of Peter the Great Polytechnic University, Krivtsov Anton Miroslavich. The number of publications of the applicant, which set out the main scientific results of his thesis according to the list provided, is two articles, including in journals indexed in the scientific databases Web of Science and Scopus, 2 publications in peer-reviewed scientific publications. From the list approved by the Ministry of Education, Russian Federation, there are no publications. The applicant submitted to the Academic Secretary of St. Petersburg University a full package of documents for acceptance for consideration defense his thesis. All the documents comply with Article 12 of Section 3 of the order. All the documents submitted by the applicant, according to the information I received from the curator, comply with the requirements that are kept and in the applicant's attestation files, copies of which are available from the Office of the Dissertation Council, Support Department, curator of today's meeting, Karpova Natalia Vladimirovna, who's currently in touch with us. Do you, members of the Dissertation Council, have any questions about the documents submitted by the applicant? Do you want me to announce the full list of documents submitted? Thank you. If anyone has questions, all the documents shall be submitted for review. There's no question with that. Well, the applicant's summary report, the floor is given to Nikolai Sergeevich. The floor is yours. Good morning, dear members of the Dissertation Council. My presentation is devoted to the solution of mechanical problems of layered structures. It's divided in 2 parts. In the first part, I will tell you about dealing with applied tasks, and in the second part I'll talk about the principle of correspondence. The relevance of the work is conditioned by the need to improve methods of oil is great importance for oil and gas production. For extraction is usually taken from landfills. As existing solutions do not take into account layered structure and results in great financial losses. There are several approaches to modeling layered structures, and some are based on considering and approaches based on simplified approaches. Doesn't depend on the number of layers. Some approaches use transform, but such methods are unstable to the number of layers. And then there are methods where number of layers is taken approximately, considered approximately. The aim of my work is an extension of the Green function calculation method, layer structures, using Laplace equation and three-dimensional elasticity equation. Solving the problem of liquid filtration to rock from infinite cylindrical tube in a layered medium, and development of the method for calculating the growth rate of pseudo three-dimensional fracture. So this layered structure can be three-dimensional and consists of layers with boundaries. So the layers differ from each other. Their size is infinite, and vertically is infinite or finite, and a layer structure may contain a layered rock, infinite long horizontal well, because a well is infinite. It's perpendicular axis. Is a round is necessary to create this axis. To solve this problem, we use the theory of complex boundary integral equation, as shown in the slide, which here the nucleus of the equation are calculated using the green, with help of green function, Laplace equation, and in theory is in detail. So finding the problem is reduced to finding green function. To find the green functions is necessary, outlined in 1994. To implement this method, we obtain all the necessary and the method was implemented numerically. The use of quick depends on influence of parameters, a transform such as the green function. This analysis was conducted for a number of tasks for which there's an analytical solution. The first task was a layered structure with all the layers have similar properties. So this is homogeneous milieu, and for this task fundamental solution is known, the Laplace equation, and analysis of the green function. Accuracy does not depend on the number of layers, and transformation influences accuracy much more. We also considered permittable, which enabled us to identify the accuracy border. It's for 128, the size of Fourier more than found in the solution. The method for construction of green function numerically was in C+ and MATLAB, and obtained a program which can be used to measure pressure in horizontal well and within one layer. In this slide you can see pressure in a layered milieu, and you can see the field is not homogeneous, and in this case we cannot use the solution for a homogeneous layer. The second problem we addressed is a well which is in two-layer milieu and in the same layer. In this task we set ourselves the task to find out how the pressure inside the well the changes of declining characteristics is very important. We study the relation between pressure point A and point 2, relation of a radius to this, the distance. The relation shows degree of influence of layered structure on the result let's mention that for a particular numerical solution with coincided with analytical solution, second task is around vertical tractions inverse equal, and it's necessary to find a formula for opening is shown in this slide. The nucleus of the equation calculated according to the green function, and so we obtained all the necessary relations for a green function for this, and the method itself was also implemented in C+ and MATLAB languages. So I didn't include any formulas in my presentation. Compared with solutions described in literature, the first problem, a large crack in homogeneous passes through in the center. The opening profile was created, and you can see that the results are published in 2001, and they use the same with the help of different method. Here we can see good coincidence. A second task of a round crack in two-layer milieu within one layer, some distance from the border. Here, see with the along the crack contour is a difference of with this difference with the results published in an article with coincide with great accuracy, but at the same time there are some differences as shown in Pierce's article. This deviation results from inaccuracies. We solved the problem in central layer of two, and we considered marginal cases of modular elasticity from top and bottom layers is much higher, much lower. The opening we also obtained a strong deviation from homogeneity. And I must say that these tasks for this we did not introduce additional conditions for the crack, so accuracy of the results always is quite high. The results green function in the elasticity theory developed a method for assessment, generalized the borders was inhomogeneous Laplace equation. We also solved the problem about the radial crack, which is in the vertical. Part 2 is dedicated to a pseudo 3D model. Is a flat crack, a perpendicular border between the layers, than its height, much bigger than its height, and has similar modulus, but a different compression tension, and the system of equations as shown in this slide consists of several equations and from initial conditions. It should be noted that in this equation the speed of crack growth does not enable us to obtain accurate results. So thus, for example, results in the pseudo three-dimensional model differ greatly from laboratory tests results. And the planar model As you can see, the results of planar model coincide with numerical model, but for that, a pseudo 3D model, good accuracy for the crack, does not give us a chance to the correspondence principle with the help of efficiency, principles of correspondence. At that, if the growth rate is equated to the growth rate coincide, the opening is also coincide. The difference is in the zone, but as numerical results show, the results do not have, there's no significant difference. So was a Python language. We create the program for modeling, and we obtained it's a modified model, theoretical for crack height with great accuracy, coincides the results of 3D model. Same way, same results were obtained in 2015, but my approach enables to calculate. So the data in the thesis can also be used to calculate crack geometry and with the opening and the planar 3D model. As you can see, the height and profile with great accuracy coincide 3D model. The results of part 2 method for calculating the growth rate of pseudo three-dimensional fracturing shows that the method can be used in the results of the thesis were published in 2 articles, obtained a registration certificate. Results have been presented at Russian and international conferences and presented at seminars of Gazprom Science and Technology Center. Thank you for your attention. Well, does anyone have questions to the applicant? The program's registration certificate was obtained for pseudo 3D crack. For other programs are used by Gazprom, and they will be certified in the future. More questions, please? No more questions. Then, yes, I have a question. I would like to clarify the advantages of methods, border elements, and dynamics, etc., etc. I think all the methods have advantages and disadvantages. What's the situation in your case? In my case, border elements and limited elements due to the fact that in presence of many of heterogeneity present at the ends only compared to the final element model, and the tasks that we have solved require the possibility the layers to be different from very thin to very thick layers, and the finite element method requires significant stabilization of the network. Otherwise, there is a risk to obtain inaccurate solution. That is why the finite element method can produce a solution quicker. So that's why we have used it. Thank you. And about the green function, should it be measured with numerical method? Then there is a question, how do we measure accuracy? To measure accuracy errors, I suggested 3 methods in my work, and comparing with homogeneous environment, and this have shown that this methods work well in given parameters of the system. For example, if we look at the number of points, if it's too small or too large, we'll see the solutions do not match. The solutions always match at desired values, or maybe the solutions in the tests and the tasks that I have dealt with, I checked accuracy, and the correspondence was very good. And one more last question. You mostly consider round cracks. What happens if the geometry of a crack changes? My model enables to calculate cracks of various geometry. Green function can be constructed for the second task of large crack. I wrote a program which can be used to calculate this the influence of this function, and this program has also been tested, and the calculation results with great accuracy correspond with other existing solutions. So for the approaches I use, this is not important. Thank you for your answers. More questions, please. No one has more questions. I have a small question. You found green function for Laplace operator, and then you use it for liquid movement in the environment. I have 2 questions. Can you widen application of your method to construct green functions for other tasks such as temperature or electrostatics, and how the properties of the environment are taken into account where these processes occur? I understand your question. Well, indeed, using my method can be used to solve other tasks, including this I explained in the article which I published. As for the second question, the connection of the flow to pressure has conductivity value through the viscosity, liquid viscosity. So there is a value which introduces properties of the milieu, of the environment, and the properties can be explored with this value, described with this value. So properties of the milieu are taken into account, but properties of the surface. Permeability is property of the surface, and then it's not important, it no longer matters for you. In general, yes. The answer is yes. In reality, properties of the environment, of course, play a significant role because the solution on the surface is connected with the for a path in each layer. So I wouldn't say that we are only interested in how the system acts at the border, but I'm interested in the properties of the whole environment. I see. Thank you. I think nobody has more questions. These are comments. Shall I ask my question now? Council members shall speak one by one, and so this now we only can ask questions related to the presentation. That's all then. Then next may proceed to the next item, is external reviews. I think no external reviews have been submitted. Then, since the reviews of the Dissertation Council members have been published at the university website, I suggest that Dissertation Council members only voice their comments or questions. If Council members have no objections to that, we can continue with speeches of the Council members. Of course, you don't have to only to vote, so it depends on each Council member. Let us proceed. Let me give the floor to Svetlana Mikhailovna. I agree there's no need to read the entire review. I mentioned relevance and everything. What I would like to emphasize, the speaker started with the main results, chapter 2, but generally speaking, Nikolai in chapter 1 describes history of, and there's quite a good review. And before his presentation, he could dedicate a couple of slides to that. That will be interesting. As for my comments, I have very minor comments. For example, the paper discusses issues of minimizing the time of green function calculation. The author mentioned several times, and the approach in which a given accuracy of green function calculation is achieved with minimum time of calculation. But he never gives any specific data about the time after I read the thesis, but I actually have discussed it with Nikolai Sergeevich, but I think he should have explained that. And one more comment I have. The text of the thesis contains a number of misprints, which is very common, but not all the designations are, for example, on page 32, the permeability introduced. Permeability is not explained, and only after next line I see the same G. It would be useful to give a more complete explanation of permeability concept used in this work, because for me this coincidence in the same page, the same letter is used for two different phenomena. I started to look for permeability, and the definition is not is not that universal. So it would be interesting it would be good if the author could explain what he means by permeability. So but this is a minor comment. The work is good, so I'm going to vote for. That's all. Well, thank you. Would you like to answer? Nikolai Sergeevich, would you like to answer now? Indeed, I agree with all the comments. In my thesis, I say minimize the time of calculation, but the time itself is not given. Here, the time should be given, but this program was tested on different systems, and in different systems, depending on parameters, it was different. But the purpose was to demonstrate that it's possible to find a minimum number of points, and the ability necessary for transformation, so we minimize the value to implement. So this was this. Also, I agree, the permeability was not introduced very well. The designation as a misprint kappa we should have used kappa instead, and then there will be no misunderstanding. Well, are you okay? Yes, yes. I have also already discussed this. Good. Next, let's give the floor to Altenbach, to Professor Altenbach. I don't want to have anything to add to my review. I think this is a very good work, and the applicant deserves the degree. What I wanted, what I already asked, I would like to see one example which is not so good. I believe this new method, which I think is very good, in fact unique. I think with one simple example it would be possible that there are some open issues and not everything can be solved with this method, but this is not criticism. So this can be done in future works. Is this all, Holm? Is all your comments? Thank you. Does the applicant has an answer? First of all, I would like to thank Dr. Altenbach for his review, and so this with this case is not that simple. Of course, I plan to continue my work because there are issues which have not been studied properly, and in the next stages I shall consider some bad cases to define the sphere of application, the application limits, where we cannot. So this is a very major and important task for me. Thank you. Thank you. Next, let's give the floor to Melnikov Boris Evgenovich. Professor Melnikov. I'd like to say the relevance and practical significance is and now my comments. The thesis doesn't track practical convergence of results, numerical calculation. Second, is not taking into account elastic deformation. Third, it's not clear whether the system is rigid. It's not specified with numerical scheme. It's not clear from the text which parameters should be used for successful application for inverse Fourier transform. It's not clear whether the value of the critical stress intensity factor. And in part 2 of the work is not clear why the planar three-dimensional model of the crack is used as a reference solution for calculation of geometrical parameters of the crack. And there is a number of misprints and stylistic inaccuracies in the work. Is not clear from the work why proposed approach is more effective than direct calculation using finite element model method. And it's very good that but this is my opinion, that the method of finite models is very popular. It can be used in non-linear tasks as alternative method can be applied. So that's why. So these are my questions and comments. Well, thank you, Nikolai Sergeevich. Please answer. Indeed, my thesis do not trace convergence of results, but I did mention it actually. In numerical implementations been calculated at each step because our task was very specific. We had a specific task. We don't take into account elastic deformation regions, but in some articles on the model used in my thesis show that for cracks this is much smaller than the size of the crack itself, and it doesn't exercise significant influence. That's why it can be neglected. As for numerical scheme, the article of 2015, Professor Linkov, he discussed application of the optimum numerical scheme for solving 3D problems, and for parameters encounter the best scheme is used, the one used in my work, backward differentiation formula. So I use the existing solution. It's not clear which parameters should be used for successful application of inverse Fourier transform. In my work, I give results, and because the results obtained with the help of inverse transformation, so these parameters can be used. I just didn't mention it. As for critical stress in the work, the 3D model is considered. Also, there's a question why a three-dimensional crack was used as a reference solution. I do this because in our cases the results of planar model coincide results of laboratory tests, so that's why we use this model. But as for misprints, already we discussed, of course there are misprints, unfortunately, though I really did my best, but also it's not clear why a proposed approach is more efficient than a direct calculation method. I will repeat myself by saying that this method was used because considered expansions of existing solutions, used practical instruments based on finite elements to obtain solution as quickly as possible. That's why. That's all. Well, Boris Evgenovich, are you satisfied? I want some clarification, please. First question about convergence. You say that convergence of which value? Accuracy, green function, depending on parameters, Fourier transform, results. So that's what I showed. Was applied to elements on the surface and studied how can some 1%. So what's over 10%? In practical cases, it's not enough. In research, the borders. Yes, this will be the next stage of my research. I have a positive opinion. Thank you. Thank you. Thank you. Now let's give the floor to Polyansky Vladimir Anatolievich, Doctor of Technical Sciences. Thank you. I will not read my entire review. This is good thesis. The contents are good. I have some comments which are not purely formal. I didn't find the review literature, and I think is necessary what is to address such practical issues. And in chapter 2 there's no introduction, and the structure of the thesis, which doesn't include literature overview with all the results. On the other hand, in chapter 2, for example, there's no introduction, and the goal has not been formulated, which can be used to address practical tasks. As for significant issues, think scientific discussion point, the main problem is singularity, round cracks or with rounded corners. I think there'll be, that will result in lead to significant errors. Not round cracks, but so then local difference of all the methods will occur, and I envisage some computational issues. Yet this is outside the scope of this thesis, and so I don't have any more significant comments, and I think it complies with the requirement. The thesis complies with the necessary requirements, and I have positive opinion. Thank you. Thank you. Nikolai Sergeevich, please answer. I agree with all the comments. Indeed, in the introduction I did not explain clearly why this method green function. Let me answer as follows. In reality, the practical instruments which are usually used for practical purposes have been published in several articles. Linkov and Pierce. Also, the method for calculating the green function in both cases includes a method for obtaining results, and Professor Pierce at that refers to Professor Linkov in that case. So he agrees that Linkov's method, and in Pierce's works, which have been published in cooperation with an oil and gas company, they contain all the necessary details, and there are questions to his method, how it can be applied to solve with free geometry. Works of Professor Linkov show that this approach in some range can be applied to more complex problems, and so that's why I use this approach in my work to solve my problems, my tasks. As for the question about more complex installations, of course this continues the question about the sphere of application of the method, because in my thesis I did not describe this, and this is a good question, and how this method will work with more complex geometry. The crack is not elliptical, and in reality that will be it's going to be my next big step to define the limits of application of my method, where our method will work well. This I'm going to do in my future work. Thank you. I'm satisfied with the answer. Thank you. Thank you. And now it's my turn. I have a positive opinion of the thesis. I think this is a real thesis. It has the essence of this thesis is in having developed a good method of numerical construction of the green function, and this is quite a complex task connected with construction of direct and reverse transform. That is why these methods later were used to solve some specific tasks which proved efficiency. Of course, the tasks are limited. These are modal tasks, though they also have practical relevance and practical significance and can be used in the oil and gas industry. I have some comments. Mostly these comments are based on the presentation or questions applied to presentation. I think the thesis was written in a short period of time, so it contains many irregulars and misprints. So I will give a short list of them. First is have a comment. In many places there are no necessary references to equations or statements given in the thesis, so it's not always clear if the idea belongs to the author or if he borrowed it from this or that source. First, that was my first point. Secondly, there's reference to Mushilishvili. The applicant uses a formula which I did not find in Mushilishvili's works. This comment, fundamental solution for a periodic homogeneous isotropic medium, is presented in the thesis as a complex multivalued function, which in fact solution is found in different sphere, which was a surprise for me. But though I see this is also a misprint, probably. Item 4, statement page 41, that some constant is a constant when variable 0. This constant, that it follows that variable 0 turns to 0 because C is in page 41, C is constant, then variable equals 0, doesn't turn to 0. And 5 figure 24 is a graph of radial crack opening. This crack tends to non-zero value, red crosses, although a crack opening along the contour should be equal to 0. Secondly, the statement page 82 that it's reasonable to take into account that before the crack has reached the boundary of the productive layer, it propagates as a radial crack under uniform pressure needs an explanation, because in the pseudo 3D model the height of the crack is much lower than the height of the crack, and propagation of such a crack is unlikely to be the same as the propagation of a radial crack. And next comment, in the second chapter, the thesis, the method of finding the crack growth rate perpendicular to the layers in the modified pseudo 3D model is presented. Comparison of the crack profiles calculation from this model using the correspondence principle with the at the same time, the natural result of this method could be a result of calculation of crack growth rate and dependence of the crack opening and crack height on the time, which unfortunately are missing. And so these are, well, more or less all. And finally, what I'd like to say is that there are too many misprints, and these misprints, I think many of my comments resulted from these misprints. Yet I think that the thesis corresponds to the requirements set forth in the order of St. Petersburg University, and I believe the applicant deserves to be awarded the degree. That's all to say. Well, then let me answer the comments. Yes, indeed, I didn't give all the necessary references, although of course I make reference to all the works, all the sources I have used and in the list of literature, but maybe not have not done so everywhere in the text. As for Mushilishvili, I checked. Indeed, the formula is not given in this work, but I tried to refer to the original sources where possible, and so they made further reference to the authors of the work I referred to. They earlier made reference to Mushilishvili's work. Maybe that's why this happened. As for the fundamental solution for the periodic structure, that was a misprint because I used everywhere R for distance. I also put it, of course, it needs a different value. So this is a misprint, really. As for the constant, if it's constant, the value is constant, the other value equals 0, I absolutely agree this is inaccurate. And of course, so the wording is I'm wrong here. As for the opening graph, is during the presentation, the accuracy is for finite cases, because no additional ideas we considered, so we gave a solution. As for pseudo 3D model, the crack before it reaches is ideal. What I meant here is all 3D models based on the assumption that the length is higher than height. There's no prerequisites there are no prerequisites for this here. Is layered structure is different compression before the crack reaches the border, so within it will crack as if the environment is homogeneous, and the model does not enable us to describe because of that. So that is why they use then this nominal solution, as if the crack grew in the homogeneous environment, homogeneous milieu, is different is in the layer. The method as for correspondence, indeed, for is reading solutions, I obtained speeds dependent on parameters, but I didn't include this in my thesis because height is calculated with greater speed, with greater accuracy. So the speed, because it led to the right result, I did not include. So I think that was the last comment, right? Yes. As for the formula, Mushilishvili, this is an example that you shouldn't trust other authors. You should check everything for yourself. Mushilishvili doesn't give this formula, but the formula can be obtained if you use Mushilishvili method. You should have found the original source where this formula has actually been produced. So if you looked through investigated publications of Professor Linkov, you might have found it. Yes, I agree. And as for complex fundamental solution of Laplace equation, there you should have installed a module. Then it wouldn't be complex. I accept your answers. Let's proceed. Since there are no comments, external comments, and we have no questions, we have not received any external questions, then let's give the floor to the academic supervisor, Anton Miroslavovich Krivtsov. I beg your pardon. I was asked to come closer. Can you hear me better? Yes, yes. Nikolai Sergeevich, I have known him for a long time, since he was a student in his second year. He was an excellent student, graduated with honors degree, and after that he started working at our center, and at the same time he entered a doctoral program. During this time, on the one hand, he studied very actively this subject. On the other hand, he always was involved in practical work. So what he has shown us today is only the top of an iceberg, and describes only a very small part of works conducted by Nikolai Sergeevich in the sphere. So here we are looking at a very versatile and mature expert, who on the one hand has the necessary qualification, on the other hand has excellent practical skills of applying the scientific results to address the needs of the industry. Also, I'd like to mention his independence. Nikolai Sergeevich, everything he did independently, most of which he has done independently, and results he obtained, he has tested many times, and in that sense, once again, he's a mature scientist. So maybe these are the main points, and reviewers gave excellent reviews, and on my behalf I believe that his work corresponds to the basic requirements, and the applicant deserves to be awarded the degree. Thank you. Thank you. Now, since we are working in the remote access mode, do members of the Dissertation Council or anyone present or the applicant has any unanswered or unclear questions regarding working in the remote access mode? If no, then I have a question for the council members. Dear colleagues, now we have an opportunity to take a technical break before the final vote and have a private discussion while the sound is off. If we don't need this private discussion, we can continue and proceed straight to voting. Do we need time for discussion? No, we don't. Okay, then let's proceed to voting. Hold on a second. Please, if we are still online, all of us, please make sure. I put the question of awarding to Markov Nikolai Sergeevich the academic degree of candidate of physical mathematical sciences, specialization 010204, solid mechanics. to the open individual vote. Let me remind you that the decision of the Dissertation Council shall be considered positive if more than a half, but not less than three members of the Council present at the session voted for it according with Article 23 of the procedure. Now, Bauer Svetlana Mikhailовna, what is your opinion? I am for. Melnikov Boris Evgenovich, your opinion? For. Polyansky Vladimir Anatolyevich, for. Altenbach Holm, for. Excellent. And me, I'm also for. And thus, dear colleagues and guests, let me declare that out of 5 members of the Dissertation Council members, 5 voted for, no one voted against, nobody abstained. The decision to award to Markov Nikolai Sergeevich the degree of candidate of Physical and Mathematical Sciences, specialty 010204, solid mechanics, has been made. Dear colleagues, since our meeting was held in the remote access mode, do council members or the applicant or others present have any questions or comments regarding the procedure of our meeting? No questions? Then time for the final word of the applicant. Thank you very much. I will try to be brief. I'd like first of all to thank everyone who first of all Anton Miroslavich Krivtsov, who since my first year provided us with the opportunity to do research, our ideas to be implemented. Vitaly Andreevich Kustin, who was my immediate advisor for supervisor for some time, who opened for me the world of science, real science. With him, I solved a number of problems to use the modern instruments. I would like to thank Professor Linkov, Alexander Mikhailovich, who for many years, and hopefully we will continue our cooperation, not only working together as a senior, as a senior colleague. He contributed a lot to me as a professional, personally. I'd like to thank members of the Dissertation Council for reviewing my work. It was very useful. I learned a lot. Thank you for your comments and the drawbacks. And in the future, I'm going to take I will improve my work in the future. So thank you from your reviews and for your participation. Okay, thank you. In that case, I congratulate the applicant on being awarded the degree and wish him success in the future with his research. Thus, our session is closed. I thank everyone for their participation. Please stop the online broadcasting.